I'm Sami. I'm one of your TAs. I'm going to talk to you today about NumPy and Pandas, and both of them are Python packages or libraries. And basically, what a library is a group of functions that have been already optimized by many people, especially NumPy because it's been there for a long time. And it has many functions that you can think of that for numerical operations, and is very useful for analyzing data. One of the other packages which are very useful with NumPy is SciPy for scientific operations. You probably will have to use it at some point for in astrophysics. Okay, NumPy is basically like a list. So as we learned, as you know in Python before, lists are, instead of using multiple or defining multiple variables, you can group all of them in one variable, but it has multiple values. And arrays are similar, but there are some similarities, like both of them to store data or objects. NumPy is for one type of data. List can have multiple types. Both of them are mutable, so you can change their elements. List you can add and remove from it easily, but in NumPy it does not add and remove easily because add a new element, because what it does, it make a new copy with a larger size and then add the element to that one. The indexing and slicing applies to both of them similarly, and since both of them have multiple values, we can iterate over them, which we will come to it later. Some differences between them are that the elements of the operators that you apply on a list, they apply on the whole list as one object or one type. But in the arrays, they apply to each element independently. So it's an element, usually it's an element-wise operations. As we said before, arrays that can hold one type of data. Arrays are already optimized to store large amounts of data in the memory. And as we said, arrays are fixed in size. Okay, so let's start. So similarly, here we define a list in a simple way. So we just have two simple arrays, 1, 2, 3, 4, 1, 4, 9, 6, 16. And to define an array, we import NumPy as NP. This is a common name between programmers to use always NP as a shortcut instead of always writing NumPy dot to call some function. So NP as a short. So to define an array, we call the function array from the library NumPy, and we give it a list. And in this way, we are using the same list as before. So we are defining two new lists, X and Y, in the similar to X list and Y list. So let's run this one. Okay, nothing comes out. So now let's do some operations. First, we will multiply the list by 4, then we multiply the array by 4, we divide the array by 4, then we divide the list by 4. And what will happen is the first operation where we multiplied the list, it multiplied the whole list as an one object. So it multiplied. So 1, 2, 3, 4, 1, 2, 3, 4 is multiplied 4 times. Similarly, if you add them, it will add them. It will stack all of them together. The list, as we said before, it will operate on element-wise. So each element in the array has been multiplied by 4, as we can see here. 1, 2, 3, 4, 4, 8, 12, 16. The division, similar to the multiplication, it will divide each element by 4. But in the list, we cannot divide by 4 because this is not a supported operation. Okay. Now, as we said before, since we have a list which has multiple values, we can iterate over them. So to iterate over them, what we do is use a for loop, because the for loop takes the variable here, an iterable, similar like an array or a list, and then for our variable that will iterate over all of them, we print it. So by printing this one, we get the values that are stored in the list. Then we print all the values that are stored in the array. They are similar, it will give the same output, there is no differences. Okay, now we come to slicing. So we usually in the list we use the index to call the value that we want from a list. Similarly in the array, and since in the list what we can do is, let's say in our X list, right? This is our X list. We can call like if it's a two-dimensional one. What we use is we use the first index like this, then we have to put it in another bracket, so in the second dimension. But in an array, so the X array, we just use the first dimension like this, then comma, then the second dimension. Okay. So this is what we have here, that we have the first dimension, second dimension. So if you have an n-dimensional array like 5, 6, 7, whatever size you have, you just separate the index of each dimension by a column. So if you have just a two-dimensional one, we just have the index of the rows and the index of the column, and then we can call that variable at that specific location. So here we will generate a random, we call the function uniform from the module random from the NumPy library. This function, we can give it a size, and in this case, we are giving it 5 by 5. It will generate a uniform random numbers, and this is our y, the variable y has this array. It's a two-dimensional one. Let me just print it like this. So we can see here that this is how the full array looks like. So we have the outer brackets, then we have the second dimension. So here the first row, second row, third row, and so on. And inside each one is the columns, first column, second column, and so on. So each one here is an element inside the array, similar to the list, where it's actually not a two-dimensional array, but it's like an array of array or a list of a list. So here we have one array, we have multiple arrays inside a larger array. And so if we try to loop or iterate through them using a while loop, what it will do here is it will take each element one by one and will go through them. So the output here, it will be if you can see, let me zoom out so you can see. You can see here that each element here is printed independently because we iterated over each one as alone. So here we iterated over the rows. And the second thing we want to do, what if we want to do print each row by the index of that one? So we come to the indexing. So y looks like this. And if we input the index here, so it will print only the first row, because what we've done here, we have only used the index for the rows and we did not use it for the columns. So, and here in the columns, it will assume all of them. The values that it can use here in the index goes like this. So for rows, columns, right? And the values that goes for the rows are like the start, end, and step. Then for the columns, there is the start, end, and step. And that default values for the start are always 0, and end are -1, and the step are 1. So if you don't use any of them, so if you don't use this the step, it will assume it's 1, and if you don't use the start, it will assume 0, and if you put a specific one, it will go for directly for that one. So with this one, with this indexing, you can slice the whole array as you like. So we can slice the rows. So let's say we want to go from the second row to the fourth one. Then we want to also slice the columns from the first column. So I don't want to put anything, so it will assume it's the 0 one, the first column, and then we go for column 2, and this is what will come out. We can see here that we are starting this is from the second row here, and then the first column, and here we got all our values. So this is a very important concept in arrays, and it's very useful when you want to slice your arrays. So by using this concept, what we do here is we iterate over the shape here. This is another attribute of the arrays. If you write y.shape, you get the dimension of the array. So we have here 5 rows, 5 columns, and what we are doing here is we're taking the first dimension, so the number of rows, and we are slashing the array here to print the rows one by one for all the columns, and we get the same output by iterating over them. Similarly, you can, if you want, we can slice over all the rows, but for specific columns. And what we get is our arrays to be transposed. So this one here is similar to the first elements here. Okay. A second concept in Python in the arrays is conditionals. So we can apply. So in our array X, let's have a look. So we have these values. Then what we can do is apply the conditional statement we learned before in Python, like in the if statement. And what it does is it gives us, it will apply this condition or this statement for each element in the array. So 1 is less than 2 and everything is false. So we have it here. And we can use this as the index or the slicing for the array. This is what we call a mask, because you can create a mask that you can apply on all the elements of the array. And if we apply it, it will give us only the elements that we want. Okay. Usually when you're trying to work with data, sometimes you have you are working on some array, you have done some operations, then you want to test some idea, then you want to apply another operation. But what you do is you make a copy of the array, then you try to edit one, but you end up editing another one. And the reason for this one here, so X, as we've seen here, is 1, 2, 3, 4. We made a copy in Z, then we have modified X, and we end up modifying Z. The reason is because we're just creating a variable that is pointing to the same location in the memory. We are not creating a new one. To do this, to create a new one, we use the function copy inside NumPy, and then we make a copy in Z, and we modify X, but Z end up not modifying. And this is what you should, this is a good practice to not make mistakes. Okay, another useful thing is stack and vstack, and this is if you want to stack different arrays together, like if you read data from different files and you want to stack them. And there are two ways you can stack them, like horizontal, so you add all of them as one array, or you are vstack, vertical stack, so you add each one as an independent element in an array. So this will come very useful later if you want to slice an array or add a new column to the array. So this is what you could do. Other useful things in NumPy that you can have like transpose operations. You can add number, the minimum to find the minimum element, the sum or the mean, the standard deviation, the max. You can reshape an array to different shapes. So if this is like 2 by 4, you can reshape it. This become very useful. There are many things in NumPy that you can look at. For example, and to learn all of them, you can just go to NumPy website and go to the guide, and this in here you can find all the functions already defined here with examples. So maybe for example, so like here indexing on arrays, you can have a single element indexing, slicing and striding. This is a good way to learn. And of course, you have other sources on the internet. And now ChatGPT is very good at Python. Another topic is pandas. So in pandas, if you want to imagine it is similar to an Excel sheet where you have different columns. Each column is a different type of data, but the data in one row are all connected to the same, let's say, star. Okay, so you have like the mass of the star, the size, the luminance, and so on. And in pandas, there are main two elements, a series and the data frame. And the series is basically a data, it's basically like an array. So if we define a list, then we can create a series from it. So it's like a one column in an Excel sheet. So if we create a series from it, from here, then what we have here is a list with all the, so we have a series here with all the elements, and then we have here an index. This index will tell us how many, the number of elements we have, and the D type, which is the data type, and the data type here is a float. So we have created a series here, and we have put initialized it with the data from the series. Then if we add multiple series together, then we can create a data frame, which is basically like the full Excel sheet. So now what we want to do is we want to take this series and we want to create a data frame from it. And in Jupyter Notebooks, it can visualize it in a way that we can easily follow up with it. So here, each series have a column ID that we can use to call the data from that column, similar to an array where it has an index, but here it is a string. So if we want to call it, since this is one column, I will do it later. So if we want to create more columns in the data frame, we can use the previously defined series. So like here we have we have the column samples. And here, what we can do here is create a new column with a new name. We can give it whatever name we want. We can use the data from that column. So df, so if we want to call samples, so this is how we call a specific column. And what we do here is we use an integer division by 1 to convert it to an integer. Then we create another column where we add 1, and another column where we multiply, square the values. And if we look at the new data frame, this is the outcome where the index will tell us the rows that we are looking at, and then we have 4 different columns because we added 3 different columns and together to the data. Now, since we have this, since we have all this data, now we don't want to waste it. So what we can do is we can save them, and usually we save them in a CSV file. And in a CSV file, let me see. Okay, we saved it as a demo. Then let me see if we can open it. Okay, hopefully, yes. Okay, so now we have saved our data frame here, and we can look at it. I'm using Colab here because it might be easier for everyone to use it immediately, but VS Code is very powerful to visualize that CSV files, and it can also have extensions that support viewing them easily, such as coloring each row or each column with the same color. So if it gets messy, you can just see them clearly. Okay, there are multiple best practices for both NumPy and Pandas. One of the main things is that you don't want to use a for loop, because a for loop is basically going to slow all of it, all your operations, and most of the operations that you will need are already optimized in NumPy and Pandas and already defined as a function, like finding the minimum value or the maximum value. So you don't need to use that, and you will come to in the activities later where you have you want to see the difference between using a for loop and without using a for loop. Okay, and so now we go into breakout rooms. Remember that we are using the roles where you have a navigator and a driver. The driver is going to type, and the navigator is going to dictate the code and follow up with that. And don't forget to keep changing and swapping between each other. If there are more than 3 people, then you have multiple navigators and one driver. Okay, so we have multiple activities, and we want to have at the end a plot. The time is a function of the list length that you need to go through the list, and here we are using time to time how much time is spent here for the for loop, and then you can go for the activity 2 and optional for activity 3.